In this section 3.3, we will talk about the behavior of the function, whether it is increasing or decreasing, and we will learn to use the first derivative test. So your goals are to determine the interval on which the function is increasing or decreasing, and we are going to apply the first derivative test. Now the definition of increasing and decreasing function is given as this. F is increasing on a given interval when you have x value, x1 is less than x2, and that their corresponding y value, f of x1, is less than f of x2. So then f is increasing. And function is decreasing on an interval when x1 is still less than x2, but if f of x of 1, the y value, is greater than f of x2, then the function is decreasing. So this one, the graph will look like this, right? Increasing, and then this one will be decreasing. Okay, here's x1, here's x2, here's x1, here's x2. Okay? So the test for increasing / decreasing function is given by the derivatives. So if f prime of x, which is the rate of change or the slope of the tangent line, is greater than 0, then f is increasing on the closed interval a and b. That's 1. 2, if f prime, the derivative, is less than 0, then f is decreasing on the closed interval. And then third one is, as you all know, if f prime of x is equal to 0, then function is constant on the interval a and b. That means that the function is neither increasing or decreasing. So you could have a function, you could have a maximum or minimum at those points. Or your graph could look like this, where if I had a graph from here to here, here, and here, if I had a graph that looks like this, so from here to here, this is where f prime of x is less than 0, so this is decreasing. From here to here, f prime of x is equal to 0. And then from here to here, f prime of x is greater than 0. So this is increasing. This is decreasing. And from here to here, it is a constant. Okay? So let me give you an example. I want to find the interval, find the open interval on which f of x is x cubed minus 3/2 x squared is increasing or decreasing. So first of all, we know that this function is continuous everywhere and it is differentiable. So first, next thing we have to do is determine its derivative, which is 3x squared minus 3x. Now we want to find the point where it's going to change from increasing to decreasing or decreasing to increasing. So we're going to look for a critical number, which then we set this equal to 0. And then we're going to solve for x for where there are critical points max and min. So we still do the same thing, factor out of 3x. And what we get is x minus 1. So we have 3x equal to 0, x minus 1 equal to 0, x is equal to 0, x is equal to 1. Those are my critical numbers. That's where the maximum or minimum occur. So now what we're going to do is we're going to set up a number line and determine whether the function is increasing or decreasing at those points. So we know that the derivative here of 0 is equal to 0 and f prime of 1 is equal to 0. So we're going to test some points on either side of the critical numbers. So I'm going to test negative 1. Oh, let's test 0.5. And we are going to test 2. Okay? So we're going to take these values, negative 1, 0.5, and 2, into our derivative. So f prime of negative 1 is equal to, so when I plug in negative 1 times 3 times negative 1, what we get is, this is 1 times 3 is 3. This is plus 3, right? Which makes it 6. So this one is increasing. So we are increasing here. Now, f prime of 0.5 is equal to 3 times 0.5 squared minus 3 times 0.5. And this is 0.25, so this is 3/4 minus 1.5. And if you notice, this is bigger, so this is decreasing. This is going to be a negative value, so 0.75, so negative 0.75. And then, so we're going down. And then, so then at 2, f prime of 2 is equal to 3 times 2 squared minus 3 times 2. And in this case, you got 4. That's 12 minus 6, which is 6. So this is increasing from here to here. So the intervals for where the functions is increasing, so it is increasing in the interval from negative infinity to 0, and also from 1 to positive infinity. Here and here, that's increasing. And it is decreasing in the interval from right here, from 0 to 1. These are my intervals for which the function is increasing and decreasing. Okay? Now let's do the first derivative test. So the first derivative test is similar to what we just did. Oh, the first derivative test so we're going to make the function to be continuous and differentiable. So function is continuous and differentiable. And what this says is that if f prime of x changes from, so the derivative changes from negative to positive, at x equals c, then there is a relative minimum at c comma f of c. So if I had a graph that looks like this, it goes from negative to positive. So from here to here, so here's C, this f prime of x is less than 0. And on this side, f prime of x is greater than 0. So it's going from negative to positive. This right here, f of c, this point right here, that is our minimum. Okay, relative minimum. So then the second one says if f prime of x changes from positive to negative at x equals c, then there is a relative maximum at c comma f of c. So what this graph is saying is this: if I had a curve like this, and here's my c, this is f prime of x is greater than 0, so it's increasing. And on this side, f prime of x is less than 0, so that means negative. So this point right here is a maximum. Okay? And third one is that if f prime of x stays positive or negative on both sides of c, then c comma f of c is neither maximum or minimum. So here's a graph. If I had a graph that goes like this, so here's C, well, slope is positive, slope is positive. This is neither a maximum or a minimum. If I had a graph that goes like this, and the derivative, let's say here's C, this is negative, this is negative. So this is neither maximum or minimum. Okay? So let me give you an example for this one too. example, we're going to apply the first derivative test. It's going to say find relative extrema of f of x is equal to 1/2 x minus sine of x in the interval from 0 to 2 pi. So, first thing you gotta do is take the derivative, and we gotta find our critical numbers. So derivative of 1/2 x is 1/2 minus the derivative of sine is cosine of x. And to find the critical number, we gotta set it equal to 0. So 1/2 equals cosine of x, and I'm just gonna add cosine of x to both sides. So then I have cosine of x is equal to 1/2. Well, cosine of x is equal to 1/2 in my unit circle. So 1/2 will be at pi over 3. And also, if I were to go around the circle, pi over 3, 1, 2, 3, 4, 5, and also here at 5 pi over 3. So x is equal to pi over 3, and I have at 5 pi over 3. So just like the what we did with finding increasing or decreasing behavior, we are going to draw that number line. I have pi over 3. I have 5 pi over 3. And I want to know whether those points are relative max or relative min. So we're going to pick a point here, here, and here. And I'm just going to pick, let's pick pi over 4. I can even pick pi. And let's pick, what do we want to pick? 7 pi over 4, right? I think that's a pretty good circle right here. 1, 2, 3, 4, 5, 6, 7. 7 pi over 4. All right, so then to find the derivative at pi over 4. So f prime of pi over 4 is equal to 1/2 minus the cosine of pi over 4. Well, that is 1/2 minus cosine of pi over 4 is square root of 2 over 2, which then makes it 1 minus the square root of 2 over 2, which makes this a negative value, so it's decreasing. So I have a decreasing value, and then I'm going to find at pi, and at pi this is 1/2 minus cosine of pi, which makes it 1/2 minus a -1, which makes it a +1. So this is positive. So from here to here, it's going up. And then at 7 pi over, so f prime of 7 pi over 4, that is same as the cosine of 7 pi over 4 is going to be 1 minus square root of 2 over 2, which is equal to 1 minus the square root of 2 over 2, which is also negative, so it's going down. So if you look at our number line here, we know that this is a minimum, and this is so negative to positive, positive to negative. So this one is our maximum at this point. So we have relative minimum at x equals pi over 3, and relative maximum at x equals 5 pi over 3. So the key to this is I would make this number line right here and show the behavior of the graph. So you got, these are my critical numbers. Pick points, one before and one after, those critical numbers. Plug it into the derivative, find their signs, increasing or decreasing. So negative makes it decreasing, positive makes it increasing. So then you can see the behavior of the function. So then by the behavior, going from negative to positive, make this a minimum, and positive to negative makes it a maximum. We will go over more questions in class. I hope you could come to class with more questions.